Welcome to the last lesson of this week where we're going to apply what we've been learning about weirs and about how to measure flow through control structures. The objectives here include using the if statement or if function in Excel and actually to use nested if statements. The application for that objective is that we're going to use this function with the Weir equations to calculate flow rates in gallons per minute for a small set of time series data. Some researchers and practitioners program Excel automatically to decide which Weir equation to use. Colleagues in this field, they use user-defined functions or by writing macros using Visual Basic for applications. I don't do that specifically for my lab group. That's an intentional decision to not use user-defined functions because when you do that, it hides all of the decisions. So there's no way for a student to understand the decision points that need to be made when you're using a variety of different Weir equations. For this educational objective, I far prefer to use if statements or if functions in Excel so that the equations and the decision points are fully transparent when you just look at a cell. For me, this approach, doing it like this, is all about transparency. Okay, so we're starting with a little template that I've made up already, starting on the left of the screen. You see column A is just a series of dates for our, like I said, time series data. Column B is pressure transducer data. This we'll paste over from some pressure transducer data that we have recorded from the field. This comes over in feet. Of course, you could use meters if you wanted to. We also need to know the height of our stop logs because this is essentially the height of the weir. So we need to subtract that out from the pressure transducer total depth data that gets recorded. We'll be calculating the depth of the weir. That'll be in feet first, and then we'll have a simple conversion to inches. And then lastly, we'll use our Weir equations in column F, and that'll give us flow rate in gallons per minute. We also know that we're using for these data a 6-inch control structure, 6-inch diameter tile pipe coming into that control structure. From the information for the rectangular stop logs, we see that a 6-inch control structure has a width of 6.34, so I've put that into a cell. I also have done a calculation, just as a quick calculation, which will become important later. We also know that the V-notch weir we're using has a depth of 6.5 inches, 6.5 inches. So I've entered that into a cell. Basically, this depth of this red line right there, that's 6.5 inches. I've pasted all of the equations that we'll need into my template. So our V-notch weir equation, Q is in gallons per minute, H is in inches. And then we know we're using this set of equations here in the case that we need to use a compound Weir equation, which is basically this scenario or this scenario. Let's paste in our pressure transducer data. So I have it coming from another source. I'll paste it over here, and I'm just going to do paste as numbers, just in the happen chance that there was formulas being used in this other source. Let's paste as numbers. So there's no risk of linking between spreadsheets, which is a big no-no in my lab. And then the first thing I do when I start to look at data is that I graph the data. This is a quick quality control check, probably the first easiest thing you can do to make sure your data don't have any weird missing values or anything funny happening with the data, like a flat line where it shouldn't be or real spiky lines where it shouldn't be. This is your first step for quality control. Just graph it. So those data look fine to me. Looks like we had water in the control structure. That water level kind of dropped over time in the control structure. Then maybe we had a flow event. So that makes sense based on what I might have observed in the field. The next part that I'm going to enter here is the height of the stop logs. And I actually like to enter a count of the individual plates that are in the stop log or that are in the control structure. So I'm going to enter this as, say, from my field notes, I know I had a 5-inch plate plus a 7-inch plate plus maybe the depth of the V-notch weir below the V, this little depth right here. Maybe that's 4.125 inches. I'm going to divide by 12 because I know those heights of those plates in inches, but I need, you can see row 2 says I need this column in feet, so I divide that by 12. So I get 1.344 feet. That's the height of my weir. So water will not flow through that control structure unless I have a water depth that's 1.345 or more feet. Okay. Remember, these stop logs are adjustable, but say we left those stop logs the same until maybe 5:14. And then based on my field notes, on 5:14, I added another 5-inch plate. Oops. And I'm going to go ahead and highlight that cell just to indicate a reminder to myself that I changed the stop logs in the control structure on 5:14. And that's information that would come from your field log. Let's do our first if function. Depth over the weir. So this is a simple subtraction, but I'm going to go ahead and use an if function here. So I have an extra set of parentheses there. If this, my pressure transducer height, minus my height of my stop logs, is less than 0, that would be basically this first scenario here. The height of the pressure transducer is less than the height of my stop logs. If that's less than 0, then I want it to give me a 0, else I want it to give me what this value actually is if I just subtract them. And then I have to end the formula by closing my parentheses. And I'm just going to double click this little box in the corner, and that drags the equation down for me. You can see there are a couple places, like on the 7th, where I only have 1.34 feet of water in that control structure, and so I don't have any drainage occurring. The syntax for the if statement is that it provides a decision point. It can have two results. If the condition is met, then the first result that you enter is if that condition is met. The second result that you enter is if the condition is not met. So for example, when I said if B3 minus C3 is less than 0, that's my condition. This first comma means then. So if this statement is true, then do, in this case, a 0. Else, this second comma means else, or otherwise, do the second part, or the third part of the equation. So if some condition is true, then do this first thing, otherwise, do the second thing. The if function is one of the most popular functions in Excel, and it allows you to make logical comparisons between values and what you would expect. Okay, so next column, I'm just going to convert this times 12 into inches. I think that should make sense because our equations have h in inches. And here you also see h in inches. So this just simplifies the equations that we're going to type in. Now we start with our flow rate equations, our weir equations. So I'm going to do equals. And this is going to be a set of nested if-then statements because there's several conditions that I want to check for. First of all, I want to check if the water is this low. If it's that low, then I don't want my equation to calculate any flow for me. I just want it to give 0. The second thing it's going to check is if the water is in this V. If the water is in the V, then I just use a straight V-notch weir equation. Third thing it's going to check is if the water depth is over the depth of the V, then I need to use a compound weir equation. And that takes two forms. If the water depth is over the V, but if my H is less than this condition, then I need to use this first equation plus my V-notch weir equation. If that condition isn't met and my water depth is really high over the V, greater than 0.44 W for this given control structure size, then I need to use this second equation plus the V-Notch-Weir equation. Okay, so there's multiple conditions that we're programming in with the if statement. So let's start. If that is 0, which you see like on May 5th it is, then just give me 0. I want to tell Excel, don't try to calculate any Weir equations. If we've calculated that there's no water flowing over the Weir in column E, then don't calculate anything, just give me a 0, because I know there's no flow. Okay? Otherwise, and here's where the nested part really starts. If, parentheses, this cell, my depth of water in inches over the V, is less than, you see here, inches is the depth of the V, 6.5 inches. I know my V is 6.5 inches tall, and I'm going to lock that in place. If my depth of water is less than my depth of the V, then let's do the standard V-Notch equation formula. So 1.44 times H raised to the 2.28 power. Okay? So this basically says if my depth of water is in the V, then let's use the V-Notch-Weir formula. If it's not in the V, then it must be above the V, so I know I need to use a compound Weir formula. So then I'm going to go comma, again another nested Weir equation, if, because I need to provide a decision point, is my water this high or is my water this high? So we have another if statement coming in now. If my depth of water in the V minus 6.5 is, I'm going to put that in parentheses, actually want an extra parentheses here, is less than this cell, 2.78. I'm going to lock that in place, and you can see this 2.78 just came from this value here, 0.44 times W. W, for my 6-inch control structure, the width of the plate or the width of the inside of this control structure, that width is 6.3 inches. So when I multiply 0.44 by 6.3, I get 2.78. Okay, and that's why that's part of my equation. So if the depth of water minus the depth of the V is less than that condition, 0.44 times W, then I do my V-Notch-Weir equation, 1.44 times 6.5, the depth of the V raised to 2.28, plus this first equation here, 3.19924 times W 6.31, and I'm going to lock that in place, W minus 0.437 times my height, I know that's E3, well actually it's not just E3, it's E3 minus 6.5 because I have to subtract out the depth of that V from my height of water. Times my height, E3 minus 6.5, all raised, that last part raised to the 1.48. Okay, let's see how my parentheses are working out. Okay, so you see my last if statement. If the height of water minus 6.5 is less than this condition of 0.44 W, then this is my whole calculation for when the water is basically right this high. That's my whole calculation. I still need this. The last part of that if statement is the case to calculate when this condition is not true. So the case to calculate when this condition is not true is this equation down here plus the V-Notch-Weir equation. So comma, This is getting very long. I think you can see that. So we're going to do the V-notch-Weir equation times 6.5 using the full height raised to the 2.28. Put that in parentheses, plus, this one is a little simpler, 3.3268 times my width of the structure, 6.31, lock that in place, times, here is my height again, and that's E3 minus 6.5, because for the rectangular portion of the compound Weir equation, you only use that top portion of water, not the whole water depth. So E3 minus 6.5, and that's raised to the 1.2. Okay, so that closes that. My parentheses now closes that if statement. I need another parenthesis to close that green one, and then closing the purple, closing the orange, now closing the black. Let's make sure that works. 22 gallons a minute. I'm going to go ahead, because I've locked all of the cells in place except for E3, I'm going to make sure I did that. This one is locked, that one is locked, that one is locked, that one is locked. By pressing my F4 key, I'm going to double click my little button and I get my flow rates. One quick thing I want to do to graph, I'm going to pull my graph reference over and look at my flow rates. And I can see I had a change in control structure here when I changed my stop log management. Even though my depths of water were higher than my original height of my weir, after I changed the stop log, added an additional weir plate in there, I didn't have any flow resulting. So just for posterity's sake, for a little extra transparency so you can actually see my equation, I'm going to copy my equation, Control C on that. I'm going to come down here, I'm going to do, let me come right here, I'm going to do an apostrophe so it doesn't recognize it as a formula, so I can just paste the formula in with it recognizing it as text rather than an actual formula. And there you see, that's the full formula written out. See you next week.